Imagine the deepest parts of our planet. The last real wilderness is dark, quiet. Now picture giant robots down there, strip mining the seafloor. That's basically the idea behind deep sea mining. It's this new industry, and it's causing a huge dilemma. So in this deep dive, we're unpacking what we're calling the abyssal dilemma. We'll look at the push for mining, the potentially massive consequences, and maybe some alternatives that could mean we don't need it at all. You shared some really interesting sources, and our mission is basically to pull out the key insights for you. So the big question hovering over all this is deep sea mining some kind of necessity for a green future? Or are we maybe about to make a terrible mistake for the planet's biggest ecosystem?
Well, let's quickly define it. Deep sea mining. It's about getting minerals from the ocean floor, usually deep down, like between 2,000 and 6,000 meters.
Really deep.
Oh, yeah. This can happen in a country's own waters, their exclusive economic zone, or out in the international area. That bit's legally called the common heritage of mankind.
Common heritage. Okay. So what are they actually after down there? What minerals?
It's the critical stuff. Nickel, cobalt, copper, manganese, some rare earths, all vital, supposedly, for things like EV batteries, wind turbines, that sort of tech.
Right, the green tech minerals. And there are different types of deposits they target?
Exactly. Three main types. First, these things called polymetallic nodules. Picture potato-sized rocks just scattered on the abyssal plains, like in the Clarion-Clipperton zone.
Okay.
And here's the kicker. A single nodule takes about 3 million years to form.
Wow. 3 million. That's not exactly renewable, is it?
Not on any human timescale, no. Then you have seafloor, massive sulfides. These form near hydrothermal vents. They're rich in copper, zinc, gold.
Hot spots.
Sort of. And finally, cobalt-rich crusts, found on underwater mountains, seamounts, valued for cobalt, obviously, and nickel.
So, given the depth of the difficulty, why is this heating up now? What's the sudden urgency?
Yeah, good question. The biggest driver is definitely the green transition. Demand for these minerals is projected to shoot up maybe 6 times higher by 2040 or 2050 for clean energy stuff.
It's six-fold increase. Okay.
And there's geopolitics, too. Countries worry about supply chains, like China controlling a lot of the processing for some metals. So deep sea mining gets pitched as a way to, diversify.
But isn't that a bit of a paradox? Using minerals from the deep sea for climate solutions, but potentially disrupting the ocean's own role in regulating climate. It's the planet's biggest carbon sink, after all.
That's the core of the dilemma, precisely. Which brings us to the environmental costs. What are we really looking at?
Yeah, let's get into that. The toll.
It's pretty grim, honestly, and multifaceted. First, just the direct destruction. Those collectors, they're like giant undersea strip miners. They just remove everything.
The habitat itself, gone.
Gone. Permanent destruction of unique ecosystems. Recovery, if it happens at all, would take centuries, millennia, maybe. Effectively irreversible.
Centuries to millennia. And the life down there, you mentioned sources saying most of it is unknown.
That's right. The deep sea has incredibly high endemism. Something like 90% of the species haven't even been described by science. One expedition just last year to that Clarion-Clipperton zone found 5,000 potentially new species.
5,000 new species in one go. So mining risks mass extinction of life we literally don't even know exist yet. It's like burning a library before you've cataloged the books.
That's a good analogy. Then there are the sediment plumes, these clouds of stirred up muck.
Right.
You get one from the collector on the bottom, the benthic plume. It could just smother organisms for tens, maybe hundreds of kilometers around the site.
Smothering life far beyond the actual mine site.
And then there's another plume, the midwater one, from waste, discharged from the ships up top. That can clog the gills of filter feeders, introduce toxic metals into the food web, potentially impacting fish we actually eat.
Toxic metals getting into the food chain. And what about noise and light? It's supposed to be dark and quiet down there.
Absolutely. Constant 247 industrial noise. Sources suggest it could travel up to 600 kilometers, messing with whales and dolphins, their communication, their navigation.
600 kilometers.
And the intense lights from the robots in perpetual darkness. It causes stress, even blindness, in creatures adapted to the dark. Plus, stirring up sediment might release stored carbon, weakening the ocean's climate regulation role.
Okay, so the impacts sound immense. But the argument is we need these minerals, right? Is that actually true? Is mining the only way?
Well, that's being questioned. The economic case is pretty speculative, actually. Mineral markets are volatile nickel, and cobalt prices have dropped recently. Battery tech is evolving fast, moving away from cobalt and nickel sometimes.
Like LFP batteries. Or sodium ion.
Exactly. And terrestrial mines still yield vastly more metal per hectare. So the economic necessity isn't quite as solid as proponents claim.
Which leads us to alternatives. Is there another way?
There absolutely is, and it's powerful. The circular economy.
Ah, recycling, reuse?
Yes. Think about the urban mine, all the minerals locked up in existing products. By the 2030s, we'll have a huge wave of old EV batteries reaching end of life. The IEA estimates recycling could cut the need for new mining by 25 to 40% by 2050.
That's substantial.
And it's not just recycling. It's reused, like using old EV batteries for energy storage. It's repair, remanufacturing, designing products to use less material, or substituting materials altogether.
Right, a whole system approach.
Yeah, one WWF report suggests combining all these strategies could slash critical mineral demand by nearly 60% by 2050.
58%. Wow. So we might not need any new destructive mining if we just get smarter.
That's the potential, yes. And here's a crucial point. Deep sea mining actually works against a circular economy. It pulls investment away from recycling and could even undermine the economic case for it.
They're fundamentally incompatible then. So who's regulating this space? And who's pushing back?
The main body is the International Seabed Authority, the ISA. But they have this kind of conflicting mandate. They're supposed to promote mining and protect the environment. Lots of criticism that they lean towards exploitation.
A conflict of interest, basically.
Many see it that way. And because of the huge uncertainties and risks, there's a growing movement calling for moratorium, or at least a precautionary pause. We're talking 38 countries now: Germany, France, Canada, the UK, plus over 700 scientists, and even big companies like Google, Samsung, BMW, Volvo.
Big names saying, hold on.
Yeah, citing the lack of scientific knowledge and the risk of irreversible harm.
Okay, so wrapping this up, it feels like the argument for deep-sea mining rests on pretty shaky ground, speculative benefits, definite high risks. Meanwhile, the environmental damage seems certain, potentially catastrophic, and irreversible.
That sums it up well.
And importantly, there's a viable alternative pathway already taking shape through the circular economy. So for you listening, the abyssal dilemma really seems to come down to this choice. Do we go for the short-term, uncertain promise of extraction from the deep? Or do we invest in the long-term, certain value of keeping our largest ecosystem healthy and functioning? Which path do you think holds more real value for our future? Something to think about.